Okay, let's talk about the problems associated with Chapter 7. And these are just very introductory kinds of capital budgeting questions. So first, let's look at some projects. We have two projects, A and B. The investments in those cash flows, we know what the discount rate is. We have a reinvestment rate. And we want to be able to calculate using the techniques of capital budgeting, we want to find out whether these projects are acceptable or not. So in this example, if you look down below, we have the answers here. We'll look at another slide here in a second. But to calculate net present value, again, you input these into the slide. So if we look at the next slide, this is the project B. Here's the investment. Here are the cash flows. And of course, it has a net present value of $147,000. Payback period is 2.2. Discount is 2.8. Now, as a management team, we'd have to figure out what number we would want here. If we wanted 3 years, then, again, in this case, both of these numbers are less than 3, so the projects would be acceptable. The internal rate of return is 40%. That's greater than 15, so this is a good project. Modified internal rate of returns, 29%. That's greater than the reinvestment rate of 17%, so that's a good. So in general, this is a good project, or project B is a good project. So again, looking back, here are the numbers from that we can make this different kinds of analysis. One of the things we can do, since we have these two projects, we can use something called the project analysis worksheet. In this case, we want to input the projects in into the project analysis worksheet. And here's our net present values that we've talked about. And we want to find out, should you do project 1 or project 2? This incorporates something referred to as the incremental cash flow. So you take project 1's cash flow minus project 2's cash flow. Here is the result of all those, the differences here. So in this case, it says, look, that if the incremental cash flow has a negative net present value. So what that means is that project 1 has less value to the firm than project 2. So in this case, you should reject project 1 and do project 2. Of course, that's what we showed with respect to the answers, right? You can see here, obviously, that the net present value of project A is $86,000 and B is $147,000. And across the board, all the numbers are better for project B than it is for project A. A second problem, right? We have a cost to start the production is $15 million, and this product's going to produce approximately $9 million a year for 2 years. Again, how do we do this? Again, you go back to the capital budgeting technique spreadsheet, and you put in negative $15 million as the cost, $9 million for the years 1 and 2. The internal rate of return that you find is 13.06% or 13.06, and the payback period is 1.67 years. So if you were to input this in the net present value profile, what it would look like? Again, if you input this or put this into the into that capital budgeting technique spreadsheet, you can see what the net present value profile looks like for this particular project. And again, you would find out that the net present value is 0, where the internal rate of return is 13.06%. You're going to have a startup problem. We're going to borrow $15,000, and then we're going to pay back. You're going to get a payback from the project of $17,250 in 1 year. The opportunity cost of lending money is 12%. again, using the capital budgeting technique spreadsheet, what should we do? The net present value is $401. The internal rate of return is 15%. So should you do these projects? Well, the project provides positive net present value and an internal rate of return that's greater than the opportunity cost. So they are good projects. The question here is, at what interest rate would the net present value be zero? Now, I'm not familiar with, I don't know how familiar you are with Excel, but Excel has a data analysis add-in that you can add to the spreadsheet, and it has a solver function. And essentially, you use that solver function that says you want to find where the net present value equals zero by only changing the discount rate. And what that would do is ultimately it would come out and say if the internal rate of return was if the discount rate was 15%, then this project would have a net present value of zero. So again, there's several ways you can ultimately find internal rate of return. We can talk about net present value in a variety of ways. The last problem we have to look at here is we have 3 projects, and we want to analyze these 3 projects, and we want to look at their net present value profile. So there is a spreadsheet that's called the net present value worksheet. And if we look at this worksheet, find out that you can, here is the, you put in the cash flows, it calculates net present value and internal rate of return. You put in the discount rates, obviously, that we have. Now, you're able to then create what's referred to as the data table, right? The net present value profile. And again, based on the numbers that you input, the discount, the rate incrementals, etc., you can get a picture of the range and what happens to net present value. And in this example, you can find that there's obviously different models at work here, right? We have one that's working a little bit differently, right? It says that as the discount rate increases, the value goes up. That is contraindicated. We know that as discount rates go up, that means risk goes up. When risk goes up, value should go down. The orange one here looks like it's going to ultimately bend back down, and then we would have 2 internal rates of return. And then finally, the third one here is the one we normally expect to see, a downward sloping net present value profile. And again, where it crosses the 0 axis is the internal rate of return. In this case, these projects all relatively very closely together have about the same internal rate of return, just a couple of percentages off. Here's 10.3, 13.9, 11.79. You can see that they have an internal rate of return that's pretty close together. So those are the problems that you might be asked to solve for from Chapter 7.